Hi, so this is sort of a project that I've been putting off for a very long time. Never really pulled the trigger on until now. And what this is going to be, or what I'm aiming for this to be, is sort of a series of video tutorials teaching kind of beginners and introductions into using Three.js for creative coding. And I think the title will be something along the lines of like Three.js for like makers or something like that. And that's going to be sort of the target audience. It's going to be people who maybe don't have a super technical background, maybe are multidisciplinary, don't have a CS background, basically. And I don't have one either. I have undergrad at NYU's IMA program in Shanghai, so I worked with a lot of different technologies, really jack of all trades, master of none kind of thing. But I've been working with Three.js for several years now, and I feel like I have a pretty good understanding of how to work around in that space. And really, what I'm going to be aiming to teach is just going to be like introductory stuff that to get you started, and stuff that I wish I knew when I was going into it, because I felt like it was very daunting. I didn't have a super technical background, like I said, so reading through all this documentation, working in like vectors, 3D space, like having random WebGL thrown at me, I was very confused. I had a very hard time understanding all these things. So yeah, I'm going to be hopefully providing something like simple and easy to use, and really working with those things. And again, if you have a CS background, honestly, you might find it easier to read through documentation, dig through old code, and like look through the examples. For everyone else, though, I'm hoping to provide kind of a base of like what I consider functional knowledge, I guess, if you will, to just get started in the space so you can get into creative coding and what I feel like is the necessary skills to actually get into creative coding. I'm not going to be teaching like memory management, super efficient coding. Honestly, what I do might not even be like the best practices. It's just what's worked for me, what I've learned just from like working in this space and like learning from all these different like tutorials from random corners of the website or of the internet. And so that's really what I'm going to be teaching. Hopefully, some of you guys have your own technical backgrounds or your own, prerequisite knowledge from other places, and maybe you guys can like suggest improvements to what I'm saying, or even like just take what I'm teaching you and like improve on it on your own in terms of methodology and things like that. But yeah, that's the goal of this. I hope it's going to be helpful for people who are watching. Yeah.
Okay, so for Three.js, you're going to need a couple basic things in pretty much every scene or sketch you're going to do. So one, you need a camera, excuse my handwriting. Two, a render. And three, a scene. You basically need that every single time. So the camera is basically just going to be the POV that you're filming from, and similar to a lot of other 3D softwares like 3ds or Cinema 4D, when you're working in 3D, you basically need this camera to basically see, to set your field of view and like how far to render things and how close to render things. If you're coming from more of a 2D background for creative coding, using like P5, for example, cameras are really useful in basically setting the size of your canvas. Since in 3.js and 3D space in general, you have this like almost functionally infinite canvas, right? Where you can go like in front of you, behind you, left, right, and there's no such thing as really just like your canvas, because it's not confined to what's you can see on your screen. There's a lot more. So you basically have to set what's actually viewable and what's going to get projected to the actual screen. There's a lot of like complicated like math and physics on how you kind of go from like world space to like 3D space and things like that, but that's not really going to be that important for us, for the most part, at least not right now. Renders, there's a couple different renders, but for the most part, I almost always use the WebGL renderer. I think most time you will be as well. Three.js is built on WebGL, so WebGL is, if you can already write WebGL, you're a wizard of God and you don't need to be watching this. For our purposes, we really won't be touching it at all in terms of writing actual low-level WebGL or OpenGL, anything like that. Basically, again, this is a very overview, and some of the things I explain might not be the most 100% accurate, but more of a functional understanding, right? So just understand that like that's basically a very low-level language that is how you draw graphics, and pretty much everything on the web, all your graphics are built on WebGL to some degree, something like that. It's extremely difficult, very mathematical. There's a lot going on there. Three.js is a very simple and easy to use library that builds on top of it, so you can draw things easier in 3D space, work things easier in 3D space without having to be able to write WebGL raw and vanilla. So so we're going to be using the WebGL renderer pretty much always. And then we're going to have a scene. So the scene is basically what our sketch is. And all of this is going to draw to a canvas element in HTML. So everything's going to come down to this canvas. The stuff you're going to put in the scene is going to then go to the renderer, and the renderer is also going to take the camera settings, and you're basically going to be like, all right, this is what we want to output, and it's all going to go into a single canvas element, more or less. And so in every single creative sketch you do or whatever you're working with, you're going to have one of these, a camera, a render, and a scene. And a little bit later, we're going to go over, as we're actually coding, we'll go over kind of different parameters that the camera takes, different parameters that renderer takes, and the different things that have a scene takes. But yeah, for the most part, that's what you need to know about in terms of like what we're going to have, the composition basically of every creative sketch you're going to do. Now, inside a scene, you're going to have things like shapes. And so in this case, it'll be like primitives or geometries, things like that, right? So in Three.js, what you have is these things called geometries, which basically are shapes, or the data that will tell them kind of like the positional values, I guess, of a shape, right? And you can have materials. If you've worked with any other 3D softwares, like 3D modeling softwares, you kind of understand what how this works already. You have these as a shape, these as your textures basically, and then they combine into something called a mesh, which is the amalgamation of these things. So it takes the shapes and it takes the textures and the visuals and it combines them. And you need both of these. You'd assume, based sometimes a lot of beginners, they look at geometries and they assume that it's like the whole thing because it's a sphere, it's a box, it's already made. But no, you need a material of some kind. You need to combine these two to create a mesh. And then your mesh gets added into your scene. That's a C. Gets added into your scene, and then everything in your scene gets rendered to the canvas, like we said before. So in our very first sketch, we're basically going to just work with how do we create a geometry, how do we put it into a scene, how can we texture a little bit, and maybe some lighting stuff, some very introductory stuff of just like drawing shapes, but in 3D. First things first, you can go to this link that's going to be down below. It's going to be the GitHub for kind of this entire video series. It's going to contain all the code that we're going to start with and end up with. Hopefully, it'll make it easy for you guys to follow along and debug. You can either use Git and download it through the command line, or you can just download the zip and then open it from there. And then once we have it downloaded, we're going to open it up in whatever text editor you're using. For me, like I said, I'll be using VS Code. It's just what I've been using and I'm most comfortable with. And it's great. So I'm just going to open. Okay, once you have it open, you're going to find basically your boilerplate HTML, and it's going to have your CSS for just default to make it full screen and like make it look all nice. And it's going to inside there's going to be an index.js. The index.js file, if you go live, I'm using the live extension, by the way, the live server extension for VS Code. I'd highly recommend it if you guys are using VS Code as well. Yeah, if you run it, what we're going to get is this like floating green box with like some lights, and it's like spinning on its own axis. And for now, what I'm going to actually do is, for this video, I'm going to create a new file, save it, call it main.js. Then I'm going to switch this. And then we're going to just try to write that from scratch. I'm going to do my best to remember all by memory. Also, first of all, I don't remember syntax by memory, so I'm always looking at documentation. I'm always looking at my old work. I'm always, cheating online, looking at Stack Overflow. I think there's, no reason you shouldn't do it, and you shouldn't be expected to remember everything. As long as you remember that these things exist and that they're out there and you know how to implement them, I think that's all that matters. So, basically what I'm saying is there are errors and I have to look at my original code. Don't blame me. Yeah, hopefully kind of walking through this as we code this, it'll help you guys understand what I'm doing and why I'm doing this in this intro. So first, we're going to create a couple of global variables. We're going to create the things that I mentioned in the kind of intro section that we need. So we're going to need a camera, we're going to need a scene, and a render. Okay, those things are going to be global because we're going to be accessing them in different functions throughout. So we need to be able to reference them globally. Now I'm going to create a function called init, which is going to basically be, if you're coming from P5, it's going to be something similar to our setup loop, not loop, setup function, where we kind of set everything up or initialize everything. So camera equals new 3, that's not what I wanted, 3 dot perspective camera. Now the perspective camera is, if I'm understanding it correct from the documentation, it's a camera designed to basically best mimic real life and real life vision. So if you want things to look a little bit more realistic, that's what we're going to use. For most things, we're going to be using perspective camera. In a couple other cases, we might use a different camera, and when we get to there, I'll go over it. And if you want to look it up, the Three.js webpage has a lot of great documentation that kind of probably explain these better than I can. So I think the different parameters it takes are the field of view, I think. So I think it's like 75 is what we're going to start with. Just for this example, a lot of times we use 45. I think those are kind of common defaults, but you can change it to whatever you want. And it's just basically going to be like essentially how much of the scene you're going to be able to see, basically your field of view, right? And then you're going to look at the aspect ratio, which is pretty much always window to inner width divided by window. Oh, I can't type. Dot inner height, and that's going to give us again the standard aspect ratio to make things look realistic. You can mess around with it if you want to warp all your shapes, but this is going to be the default. And then you're going to have your near frustum, I think frustum, I don't know. Your near and your far, basically. So how close things are and how far things are for it to be rendered. So basically, I'm going to start with 0.1 and let's just say 1,000. So basically anything closer than 0.1 is not going to be rendered. Even if you create it, put it in the scene, it's not going to be rendered in the final thing. Anything beyond 1,000 in Z direction, I believe, again, not going to be seen. Or not even Z, just whatever direction the camera is facing. Anything past 1,000 units won't be rendered, even if it exists in the 3D world, right? It's not going to be rendered out for us. Okay. Hopefully I haven't forgotten a parameter. I think that's all right. And then let's just move on to our scene. Scene equals new 3. Oh, scene. That's all we need to do, except that needs to be capital. And then render equals new 3.webgl render. Okay, I believe that's all we need to do for like the initial setup. Let me double check some things. Should be correct. And now what we do with the render is set the size. Set size. So this is a built-in function called set size, and it's just gonna be window.inner width, I think, and window.inner height. And that's going to give us the full screen of our web page. And then what else do we need to do? Okay. So I briefly mentioned that everything gets drawn to a canvas element without getting too much into HTML, CSS, and JavaScript. This basically needs to be put into that kind of framework, if you will. So how we do that is, I think, document body append child render DOM element. You don't really need to understand what that exactly means, but if you want to get into it, maybe I'll have a link below about HTML and the DOM and how that works. But basically, you just need to append this to the DOM. That way, it's actually going to render out in the HTML, render out onto the web page, essentially. And again, whatever I say, take it with a grain of salt, because I don't fully understand the technical know-how down to 100%. It's just a functional knowledge. You just need to do this every time. So do it every single time, okay? If I'm looking down to the right, it's because I have a picture of my code. And I'm referencing to make sure I haven't forgotten anything. That way it just runs smoothly. And I think we're good for now. Okay, so now we have an init function. Now we need to basically have essentially our draw loop. And what that's going to look like is going to be function animate And then inside, we need to request animation frame. And then inside, we're going to pass itself in. So what that does is once animate gets called one time, it's going to request animation frame, which is going to be itself, and it's going to be self-referential. It's going to call itself over and over and over again every single frame, hence becoming a draw loop. We also need to say render, not render, and then we say, I don't know if there is an order for the scene and camera, I think. I don't know if there's a specific order you have to go in. But yeah, so you pass in the camera and you pass in the scene. Basically, it's going to say what scene are you trying to render and what camera are you trying to render it with. So basically the setting of the camera, and then that's going to be the final thing that's going to actually render everything. Now, if I haven't messed up, I think this is almost everything we need. Well, we need one more thing. We need to call the functions. We need init here, and then down here we could say animate. And then what that's going to do is in line 2, it's going to call this function. It's going to set all this stuff up for us. Then at the very end, it's going to call animate, which then is going to call stuff over and over and over and over again. Now, if we just run this, I should navigate to a thing, we see nothing, which is perfectly fine because we haven't actually put anything in our scene. Remember, from what I've mentioned before, we have to kind of put the things in the scene. Right now we have a complete empty scene, which I'm going to double check. Okay, no errors. Good. So there are no errors, which is starting off strong. So let's create something called a cube. Let cube. Okay. And now inside here in our init, let's just create a cube so we know. So what does a cube entail? Well, we need to have a geometry and a material. So let's just say let geometry equals new 3.box geometry. And again, there's a lot of different geometries and primitives that are already pre-built for you that you can use. For now, we're just going to use a box. And then I think we could just use like 1, 1, 1. I think it's like height, width, and something else similar to that. You can look at the parameters for the box geometry, but it's going to be similar to pretty much drawing shapes in P5 or anything else. You basically just need to add in the parameters that you want in order to create the boxes to the correct size that you want it to be. And then after that, let's create a material. New 3 dots mesh basic material, I think is what it is. And then color. I don't know what color this is, but it's a color, and hopefully it'll work. And again, we actually have to put these together. So our global variable that we had in line 2, cube, is going to be equals new 3.mesh, and oops, and it's going to take our geometry as the very first parameter, and the second one's going to be the material. So you pass in the geometry and you pass in the material, and now we have it. Now, if we look, nothing happens. Why is that? So when you actually, in Three.js, you have to add everything to a scene. Whatever you create, it doesn't really matter until you add to the scene. So there's a very specific hierarchy and that you have to follow. You create things, pass them to the scene, you pass the scene into the render, and the render renders it. Okay, so that's basically how it's going to work. So basically, you're gonna make this mistake a lot of times. I've done it a million times where I've like gotten really lost in my code and forgot to add it to the scene, and get very confused why nothing's happening. Just remember, and you literally say scene.add cube, and you pass in whatever that thing is, and hopefully nothing works. What am I doing wrong? What did I forget to do? Do I need a light? I might need a light. Oh, I know what I did wrong. Okay, so this is something I forgot. Basically, this is another thing that happens all the time, and it happens all the time because I still forget this. The default for pretty much all the positions is 0, 0, 0 in 3D space. So our camera right now is at 0, 0, 0. Our cube is at 0, 0, 0. So if I am correct and I haven't made any other mistakes, which is very possible I may have, we're basically inside the cube right now, which is why we can't see anything. So what we're going to do is we're going to tell the camera position dot z equals 5. There we go. Cool. So now that we move our camera back or to a z position of 5, we can actually see the cube. Now that's kind of boring. We've gone through a lot of code to do something very boring so far. I know, but it's going to get more interesting in the building blocks, right? Anyways, so one thing we could do to make it a little more interesting and a little bit more, wow, I could have done this in P5 a lot easier, is we can change the material. So let's do mesh Phong material. Now there's a couple different materials. I believe there's Lambert, Phong, and Basic, and maybe another one, I don't remember. But basically your Lambert material is going to take shading in, so it's going to be affected by the lighting. And I think mesh Phong is affected by lighting and is reflective. So, the different materials are better for different things. Obviously mesh Basic is going to be the most efficient. It's not hard to render, not hard to run. And then Phong is probably the most taxing on your computer. So if you're building a million geometries, maybe don't make them all mesh Phong because it'll be harder for the renderer and the GPU and all that stuff. But yeah, for now, since we're only doing one, let's just do mesh Phong. And if I'm doing this correctly, we should see nothing. Yeah, okay, so we see nothing. Why is that? So with what I mentioned about Lambert and Phong taking shading in, it actually needs to take shading in. So without lighting, it will basically, it's like there's some physics going on, right? So if there doesn't have a light, it won't be able to reflect anything and you're not gonna be able to see anything. So let's create a light. Let's D-light, right? Lighting. Okay, so D-light equals new 3.directional light. And I think parameters are the color and then the intensity, I think. So let's try 0, 0, 0, 0. Let's see if that is it, and 0.3. And then we need to basically add it. And we'll see if I remember correctly. Oh. Okay, is this the hex code for black? I actually always forget. Let's just try that and see if it makes a difference. Nope. Okay, so I just probably cut. Hopefully I cut until I figured out what happened. So I didn't actually make a mistake in the coding, more so in the understanding of where things were positionally. I think I forgot that without it rotating, it actually, in the default space, the light doesn't hit it correctly with where I had it. So, oops. But yeah, this is kind of some of the challenges of working in 3D. Sometimes you kind of get lost in where things are positioning because you're working in 3D space and you kind of have to just remember where things are. So yeah, as you can see in the code, I didn't actually change anything from 23 to 24. It's still set at 440. Same thing, it's white light 0.3. You can make this really anything. Just make it a 1, and then it'll just be like brighter. And the main change I did was I changed the rotation in the animate frame. So basically, it's going to rotate around its x and y axis by 0.01 every single frame. Hopefully this was informative. Hopefully I didn't ramble on too long. I'll definitely have time codes at the bottom so that you guys can skip around and get around my rambling. This is my very first video teaching how to code. So if you have comments, feedback, hate for me, please let me know in the comments or DM me. If you have questions, also let me know. I'll do my best to answer them. Hopefully, see you guys in the next one.